we have learned that an intramolecular aldol reaction is possible in 1,4-diketones, and if that's the case, the 1,4-diketone would undergo the intramolecular aldol reaction to give eventually the corresponding alpha, beta, and saturated carbonyl compound. Of course, it's a 5-membered ring. It's an enone of that specific ring size. Intramolecular aldol reactions are not only possible in 1,4-diketones, they can also be possible if we have a 1,5-diketone, something like that. So look, 1, 2, 3, 4, 5. It's a 1,5-diketone. If the 1,5-diketone is treated with catalytic base, that catalytic base should make an enolate of one of them, and that enolate would then attack the other ketone in an intramolecular aldol reaction to give eventually alpha, beta, and saturated carbonyl compound. But clearly here, since we have now 1,5-diketone, the ring size will not be the same as before. Now the ring size here should be of 6, if you like, 6, because we start with 1,5-diketone. Before we took 1,4-diketone as an example, we ended up with an enone of ring size of 5. Now, if we take a 1,5-diketone, then we should get cyclohexenone. So this should be the final product. And of course, we can keep track of carbons. And of course, if we make an enolate from the upper ketone, then we get something like that. Now, you can put the numbers. So 1, 2, 3, 4, 5, 6, 7. And of course, then this enolate attacks the other ketone in an intramolecular aldol reaction, nucleophilic addition type, obviously, to give initially beta-alkoxy ketone. You can put the numbers again just to keep track of them. So carbon number 1, 2, 3, 4, 5, 6. So the new bond is actually between carbon number 1 and carbon number 6. We can label it as new carbon-carbon bond. It's between, again, carbon number 1 or the alpha carbon in that ketone. Of course, it can be described as alpha, and carbon number 6. That's the new bond. This beta-alkoxy ketone should undergo protonation to give beta-hydroxy ketone initially. So this is the initial aldol product. You can put the numbers again. Number 1, 2, 3, 4, 5, 6, 7. And again, it's the C1, C6 bond that is the new bond that's formed in this reaction. This beta-hydroxycarbonyl compound will undergo elimination under the catalytic base conditions to give the final alpha, beta, and saturated carbonyl compound. Okay, so these are the numbers again. 1, 2, 3, 4, 5, 6, 7. So it's an enone of ring size of 6. When we get a ring size of 6, that's because a 1,5-diketone is reacted in this case with catalytic base. So in summary of this topic, an intramolecular aldol reaction is also possible if a 1,5-diketone is treated with catalytic base. The product here is still an enone. It's still an enone, but of a ring size of 6. It's cyclohexenone. Obviously, it's an alpha, beta, unsaturated carbonyl compound, a typical product of the aldol reaction.